Welcome to the Lines and Angles Part 2. In this session, we will solve few sums which are little different from our exercise sums. Here is a figure which has a triangle and some angles. With the help of the hints given in this figure, we need to find the value of a plus b. So if we study the figure, it has two parts. One is the upper part of the line segment AD, the other is the lower part of the line segment A. The lower part doesn't give any direct hint for us to solve because both A and B are unknown. And we will take this where we get some hint to proceed for the solution. So the line AD has three parts, that is angle AOB plus angle BOC plus angle COD. All these three make a straight line which is equal to 180 degrees. And angle AOB is half of x. Angle BOC is 5 times of x by 2 minus 1 plus x plus 9 degrees equals to 180 degrees. And on simplification of LHS, first I'll take LCM and write the terms in the numerator. It is plus 2x plus 18 equals to 180 degrees. And by adding the like terms of the numerator, I'll get 8x plus 8 divided by 2 will give me 180 degrees. And LHS on simplification, 4x plus 4 equals to 180 degrees. And 4x equals to 176 we get. Now x equals to 176 divided by 4. So x value is 44 degrees. So now we will take this hint to get the value of a plus b. And when I study the triangle, one of the angle of the triangle forms a vertically opposite angle to angle COD. And we will take this hint to get the required step now. So we'll write angle COD is equal to angle AOE, which is equal to x plus 9 based on vertically opposite angle. So we know that x value is 44 plus 9, which will give me 53 degrees. So this angle is 53. Now I go for the triangle, and in triangle I apply the property of the triangle. Angle A plus angle B plus angle AOE is equal to 180. We know this. And now I substitute the value of angle AOE. So angle A plus angle B equals to 180 minus 53, which gives me 127. So this is how we get the value of a plus b. Now we'll see what's the next question. Yeah, here is the next question, which is a quadrilateral ABCD, and the sides BA and DC are produced. Based on this, we have to show that angle x plus angle y equals to angle A plus angle B. When we study the figure, we don't get any direct hint. So here a little construction is needed. So what type of construction? The construction which we do should simplify our process. That is, here I divide the quadrilateral into two triangles by drawing a diagonal. Right, so I name this as angle 1, angle 2, angle 3, angle 4. Now I take the triangular property to get the required solution. In triangle BCD, angle A forms the exterior angle. So angle A equals to angle 1 plus angle 3. that is exterior angle theorem. We get the statement based on this theorem. Similarly, in triangle BAD, if we see, angle B forms the exterior angle. So same way we get angle 2 plus angle 4 based on the exterior angle theorem. So when I study the figure, I want the value of A plus B. So what we will do? We will add both. So my LHS will be angle A plus angle B, and RHS becomes angle 1 plus angle 2 plus angle 3 plus angle 4. And according to the construction, we know that angle 1 plus angle 2 was angle Y, and this was angle X before construction. So we got the required step, angle A plus angle B equals to angle X plus angle Y. So let's take the next question and solve it. Now if we study this question, diagram is not given, so is diagram needed? Let's read the question first. The side EF, FD and DE of a triangle DEF are produced in order, forming three exterior angles DFB, EDQ and FER respectively. So prove that angle DFB plus angle EDQ plus angle FER equals to 360. So according to the question, we need to draw a triangle and name it as DEF. And we need to extend these sides. Right. Now extended sides also should be named. So how to name the extended angles, we will see. DFP. So we will name it as here P, because DFP is asked. So we will name this as DFP. And next is EDQ. EDQ. So we will name this as Q. And the other is FER. FER. So this part we will name it as R. Now clear, and name this as angle 1, exterior angles, angle 2, and this as angle 3. So these forms, angle 1, 2, 3 form the exterior angles for the triangle. Now we will take the same hint to proceed for the solution. Now I'll take first exterior angle, that is angle 1. So exterior angle is equal to interior opposite angle. So this part and this part. So how to name it? So let us name it as angle 4, 5, 6. So that it is easy for us. Later we will convert it according to the question. So angle 4 plus angle 5. Right. So what is angle 1 is also equal to, according to the question, it is EDQ. So this part we got for the first. So this is angle EDQ is equal to angle 4 plus angle 5. And now next we will take another exterior angle, that is angle 2 is equal to. So angle 2 is equal to 4 plus 6. So angle 2 also can be written as FER. Angle FER. So this is what we got this with the second one. Is equal to angle 4 plus angle 6. Now we'll go with the third exterior angle, that is angle 3. Is equal to angle 5 plus angle 6. Angle 3 can also be written as DFP. Angle DFP, which is equal to angle 5 plus angle 6. So let me name this as, these three we are supposed to add, because according to the question it is given as sum of these three angles. So when I add all this, that is, let's name it as A, B and C. By adding these A, B, C equations, so what do we get? My LHS will be angle DFB plus angle EDQ plus angle FER. So this is what LHS according to the question also. And now I'll take my right hand side, angle 4 plus angle 5 and plus again angle 4 plus angle 6 plus again plus angle 5 plus angle 6. So when I take all this, so I'll get 2 times of angle 4 plus 2 times of angle 5 plus 2 times of angle 6. So I'll take out 2 common, angle 4 plus angle 5 plus angle 6. Right. So I know that in a triangle, angle 4 plus angle 5 plus angle 6 is equal to 180. So I write as 2 times of 180 will give me 360. So we got, according to the question, that angle DFB plus angle EDQ plus angle FER equals to 360 degrees. Now let's see what is the next question. Yeah, here is our next question, which is again based on the figure. Here in the figure, EF is a transversal to two parallel lines AB and CD. GM and HL are the bisectors of the corresponding angles. And we have to prove that GM, this and this are parallel. We have to prove that these two are parallel. So we will take the hint that both the lines are parallel, that this one and this one are parallel. AB is parallel to CD according to the question. Since AB is parallel to CD, corresponding angles are equal. So what are corresponding angles? That is angle EGB is equal to angle EHD. So these are corresponding angles and are equal. Corresponding angles. We know that corresponding angles are equal. And 2 times of angle EGM is equal to 2 times of angle GHL. We know that these two are the bisectors. So if this is a bisector, angle this and angle this one, both are equal. So this is equal to 2 times of this, and I'll be getting angle EGM is equal to angle GHL. And these two form angles which are equal. And they form the corresponding angles. If we compare the lines, they form corresponding angles. When we compare these two, they form the corresponding angles. And if corresponding angles are equal, then we can say that line GM is parallel to HM. So this is how we get the required solution. I hope you have understood these sums, which are explained with the help of the properties which we have learned in the previous